So our today's webinar is on BIM and how it is revolutionizing cement plant construction. Our speaker today is Mr. Kapil Goyal, who has more than 25 years of experience. He's a senior consultant and he has played a key role in implementing BIM in some of the project engineering that we have done. And I'll just give you a brief on what our webinar is all about. Our webinar today is on building information modeling and cement plant construction. So we will cover various things. First thing which we will cover is challenges that is faced during the cement plant construction and how BIM helps us address these challenges. It will also showcase advantages of BIM in improving efficiency, safety, and cost effectiveness. And we would present Holtec's expertise and experience in implementing BIM in cement industry projects. Now I would hand it over to Mr. Kapil Goyal, who will take it forward from here.
So the topic is clear where we want to focus today. BIM is most developing technology these days in the construction industry. So now we will focus on how we are implementing BIM in the cement plants. For this, let us understand what is the overall extent of a cement plant. Cement plant is considered to the heaviest industry, one of the heaviest industry in this construction industry, where we deal with very heavy vibrating machines. There are huge storages. Storages are up to extent of 50,000 ton to 1 lakh ton of materials. There is a complex network of material transfer systems, which comprises of belt conveyors, pipe conveyors, air slides, bucket elevators. There are huge interconnecting duct networks. The ducts are of almost 3 to 4 meter dia. These carries hot airs and different materials also. So these are not straight, and to support these things, we need heavy structures. And above all, the lifeline of a plant is cables, cables for electrical, instrumentation, etc. Now, to support all these complex things, we need to make structures. So a typical cement plant consists of 40 to 50 odd number of small and big buildings supporting these equipments. We have structural steel independent structures to support duct conveying systems and cables. And of course, since this is a huge industry, we have to have a administrative block, we have to have a control room, electrical load centers, and for workers, we need to have canteens and few more non-plant buildings. Let us understand what is the volume of construction to be constructed in the cement plant. So there is a RCC construction. The type of big cement plant these days we are manufacturing or things are consuming almost around 80,000 to 1,20,000 cubic meter of RCC, which are used in foundations and long buildings. The size of structures varies from small electrical building, which are 2 to 3 story buildings, to preheater, which is almost 26 meter to 36 meter into 150 meter high. The buildings are having equipments and heavily loaded machines inside them. Now comes the steel construction. So same size of plant consumes almost 12,000 metric ton of structural steel fabrication and erections. Structures are made to support complex duct systems, maintenance platforms, operating platforms, and cables. Another huge component is earthwork. So depending on the land terrain, the earthwork volume is decided. If there is a huge hilly terrain, there are a lot of levels to be constructed. We call them benches. Optimization is done to decide the levels, but of course, we have to see the accessibility, road slopes, drainage, and other things like erectability, operability, and maintenance of machines and structures. Further, to add challenges in the type of engineering we are doing in the cement plant, see, we have to deal with the main machine supplier who further purchases small bought out items from other vendors. So the engineering input which is coming out of the mechanical supplier is improperly phased due to ordering system, and this results into revision of drawings continuously. All stakeholders should have the latest revision of drawing. This is a complex thing, and then resultantly we have dimensional clashes, changes in building GAs, and structural fouling. Now we explain how BIM help to meet these challenges. I think all of us know what is BIM. BIM is a digital representation of the physical and functional characteristic of a building facility, serving as a comprehensive information resource. BIM facilitates teamwork by allowing stakeholders to visualize the entire project and collaborate efficiently throughout the construction process. And even after the construction process, this is useful. Emerging over last 2 decades, BIM is revolutionizing the construction industry by enhancing design, planning, and execution phases. So why we need BIM information modeling, that is BIM? Let us understand the key benefits to meet the challenges explained above. So this is the first benefit which we are getting out of BIM in the cement industry. It enhances collaboration among the multidisciplinary teams. We can also call them stakeholders. So we have a mechanical design by the supplier. We have a civil consultant or civil designer, structural designer. Then comes the contractor who constructs the civil at site. We have a mechanical and structural erection team at site. And above all, the construction management and planning, which is the integral part of the whole of the project from start till end. Second usefulness of BIM is the availability of latest information on cloud. So Holtec prepared and made all the latest models for the buildings available on cloud to all the stakeholders. The cloud services was of course provided by the client just to have a better control over the data as an owner. The latest drawings and relevant data were available on the cloud to avoid any confusion at site. And due to phase-wise availability of information, there are frequent revisions which are confusing. This can lead to errors and mismatches. But as per our experience, the same was better dealt in BIM. Most important part of the BIM is clash check and fouling. And this is more used in the industrial projects because lot of complications are there. And see, there are different stakeholders in the engineering of the cement plant. There are mechanical supplier, there are structural and civil designer, there are electrical engineers. Conventionally, all of them work in their separate and isolated environment. Flow of information and changes is not so smooth in the conventional method. Hence, there are chances of errors and mismatches. We have implemented BIM in certain disciplines and found that the flow of information is very smooth. Using tools for clash check, we could by and large remove the major site problems and has saved time in a longer perspective. There were lesser mismatches and no clashes in the drawings, that is between civil, structural, and mechanical drawings. Here you can see few examples. Duct is fouling here with the RCC slab. We discussed this with the supplier and he said that he cannot change the duct orientation. So we increased the opening size in the slab. Similarly, there was a clash between a bracing and another duct. Here, we need to change the system of bracing, and finally, the drawings were issued without any clash at site. So we have understood what are the challenges that we met through the BIM. Now let us understand flow of BIM engineering in a cement plant. We have categorized 10 major steps in the BIM engineering for the cement plant. Starting with the things, we start basic engineering. A technical concept is developed and accordingly flow sheets and mass flow diagrams are prepared. Preparation of tender document is done and then we review the tender and ordering is done. By ordering is done that we select a major mechanical engineering supplier who will do the further mechanical engineering. So second important step is preliminary layout preparation. The land is bought by the client according to the size required for the plant. And we start working on the contours available through the land survey, that how many benches are to be prepared. If it is a plain terrain, a single bench can do. But if there is a hilly terrain, then you need to make more benches. Here is a typical example where we have constructed 5 odd numbers of benches, and the level you can see here are ranging from 384 to 336, almost around 50-meter differences. So we worked a lot on this thing. We calculated cut and fill volume of each bench, and then check if it is accessible from other area through roads, slopes of road, and for the loaded truck was also calculated. Drainage was calculated, and ease of maintenance and lower operation cost was kept in mind. Let us see how we calculated the cut and fill volume. See, the concerned software, we provided input of contours and the land area. It developed a 3D land profile. Then we decided to have a level of the bench, and the software calculated the cut volume, the fill volume, and even it tell us what is the level at which we can balance this cut and fill. So after finalizing of the benches, then we put a rough model of each building in the process which is required for the cement plant as per process requirement. We placed it at the required locations and tried different options by shifting the buildings. Therefore, we were able to get an optimized cement plant preliminary layout. We also checked the erectability and the operational ease on the structures. Then comes the role of mechanical engineering. After finalizing the process, after finalizing the preliminary layout, mechanical engineer starts its work, preparing a model in which he places all the 3D models of the equipments in a preliminary building and serves the process requirement as per the layout requirement. He follows statutory rules. He see the local requirements, and as per client preference, he also makes sure if the building is to be constructed in RCC or steel. He also calculates and provides the load of on the structure so that structure can be designed. So after this BIM model from the mechanical is placed, it is shared with the civil and structural engineer. The structural consultant designs the required structure and prepares structural engineering model, collaborating on the same mechanical model. So here starts the collaboration, what we were talking about. And he designed the structure, taking care of the loads provided and other loads which were taken, like live loads, wind load, and seismic load as per code and as per the location. So while designing the members, he takes care of the restriction provided to the mechanical equipment. So sufficient maintenance space is ensured and collaboration model is shared to all the stakeholders. Stakeholders means mechanical, electrical, site people, planning people, all of them are now having access to the model. So all of them review the model and comment according to their expertise and their requirement. Finally, with the mutual discussion and agreement, there are changes in the model which suits all of them. And this is called collaborative engineering. And this is the main benefit of the BIM. Any fouling and mismatches are checked at this stage also. So every software which is dealing with BIM is have an integrated facility to check the clashes and fouling. So it checks the fouling with the equipment, with the structure, and make a list and highlight where is the clashes. After mutual discussion, the corrections are made in a mechanical model or the civil model to avoid that clash. And this really helps at the final stage when you are going to erect the structure or the machines, and if you are getting the fouling, then there is a total wastage of time, money to rectify the things, and further there is a mess. So after you finalize all the GA models, everything is now seems to be fit. So further detailing is to be done so that construction can be done at site. So one is rebar detailing. So as per design requirement by the civil engineer, rebars are designed and placed inside the model. You can extract drawings out of the software for these rebars. Even you can have bar bending schedule automatically coming out, and BOQ bar wise procurement can be extracted directly from this. There's one important part which is being taken care during the modeling of the rebar is the length of bar. Length of bar may be, see, maximum length of bar available from the source is 12 meter, but sometimes there is a restriction in the inventory also. And there are restrictions like total weight which can be handled during the placing of bar. So from site and the client, it is decided what length of the bar to be considered while detailing these things. And we follow the same, and there is no further modification at site, and this saves times and money. Similarly, structural steel detailing is done. Since the structural model is already finalized as shown above, the steel detailer provides member-to-member standard connections and fabrication drawings are generated. Similarly, erection GAs are also prepared through the software. Overall BOQ and drawing-wise BOQ are extracted. Even you can have the bolt list. And if client selects automized workshops, then if required, CNC files can also be extracted from the software. So now design is there in the virtual ground, that is on BIM, on papers and everything. For construction, we need material. So for procuring material, the BIM supports with exact quantity extracted from the model. They are very much accurate. This reduces wastage and cost over cost runs. There is no interference of any other agency or external agency for this estimation. So it is very much accurate. You can have RCC quantity grade wise, you can have rebar quantity diameter wise, you can have structural quantity member wise. Even if required, you can have a shuttering area extracted directly from the model. Another part is planning and management. Any project cannot be done without planning and management. BIM also supports the construction industry in the planning and management. Each model can be divided into different phases for the construction, and you can monitor and you can assign a timeline to these different phases and monitor it. The addition of timeline to different phases adds fourth dimension in the model, that is time. We already have three dimensions x, y, z, and this is called 4D model. So everything is in cloud, everything is on paper, procurement is there, but actual construction is to be done at site. BIM also supports the construction at site. We have all the synchronized model available on the cloud. Site can access those cloud models and associated drawings on the devices like laptop, tab, or mobile phone using suitable applications. We have done this in one of the project. Site can review the models and suggest suitable corrections if required. BOQs are also directly available in the model. Now let us talk about what is the situation today for implementing BIM in the cement industry. BIM adoption in the cement plant is still limited. Not all the stakeholders are actively participating. Small vendors do not provide any 3D models. Big suppliers provide only for the few buildings, and the purpose is not fully served. There is a shortage of skilled BIM professionals, especially for the cement plant or heavy industry. It is still a way ahead. Customers are hesitant due to higher initial cost and marginal increase in engineering time. This is a big question. Since we are getting certain other benefits instead of following a conventional engineering directly from the models, etc., we have to invest little more extra time and, of course, little more extra cost to reap the total benefit of the BIM. What are the action plans to get this technology on board? We should encourage more investment in BIM for long-term benefits. We should train in-house teams and consultant for BIM applications. We should promote research for automation and AI integration in BIM. This can be done either at the user end or directly by the software supplier. We should establish protocols for better collaboration and model sharing. That means disciplined approach is very much required. Otherwise, there can be further confusions. Now we explain how BIM help to meet these challenges. I think all of us know what is BIM. BIM is a digital representation of the physical and functional characteristic of a building facility, serving as a comprehensive information resource. BIM facilitates teamwork by allowing stakeholders to visualize the entire project and collaborate efficiently throughout the construction process. And even after the construction process, this is useful. Emerging over last 2 decades, BIM is revolutionizing the construction industry by enhancing design, planning, and execution phases. So why we need BIM information modeling, that is BIM? Let us understand the key benefits to meet the challenges explained above. So this is the first benefit which we are getting out of BIM in the cement industry. It enhances collaboration among the multidisciplinary teams. We can also call them stakeholders. So we have a mechanical design by the supplier. We have a civil consultant or civil designer, structural designer. Then comes the contractor who constructs the civil at site. We have a mechanical and structural erection team at site. And above all, the construction management and planning, which is the integral part of the whole of the project from start till end. Second usefulness of BIM is the availability of latest information on cloud. So Holtec prepared and made all the latest models for the buildings available on cloud to all the stakeholders. Cloud services was of course provided by the client just to have a better control over the data as an owner. The latest drawings and relevant data were available on the cloud to avoid any confusion at site. And due to phase-wise availability of information, there are frequent revisions which are confusing. This can lead to errors and mismatches. But as per our experience, the same was better dealt in BIM. Most important part of the BIM is clash check and fouling. And this is more used in the industrial projects because lot of complications are there. And see, there are different stakeholders in the engineering of the cement plant. There are mechanical supplier, there are structural and civil designer, there are electrical engineers. Conventionally, all of them work in their separate and isolated environment. Flow of information and changes is not so smooth in the conventional method. Hence, there are chances of errors and mismatches. We have implemented BIM in certain disciplines and found that the flow of information is very smooth. Using tools for clash check, we could by and large remove the major site problems and has saved time in a longer perspective. There were lesser mistakes. Now, what is the Holtec experience in the BIM implementation? Holtec has done few projects on the BIM, and that is also not to the full extent. There is still way ahead to get the full BIM implementation. We have calculated cut and fill volumes for few projects to facilitate the client to decide the bench levels. Civil engineering and structural engineering models were totally prepared, but they were prepared using 2D mechanical suppliers drawing. All civil and structural GAs were prepared through the BIM models only. Detailed BBS and fabrication drawings were also prepared using the same. VOQs were extracted from the same and were very much accurate. We got a feedback from site that all payments for bar bending and RCC work at site were made through the quantities extracted from the BIM. But there were some modification which they have agreed mutually to pay some extra or cut some extra. But by and large, the payments were made through the BOQs extracted from the BIM. Models were uploaded to the cloud and were available even at site. Models were used later for the further modification. In one of the project, we completed the project, construction was done at site, and after 2 years of completion, they required some modification in the process. Since we had the as-built model of that particular building, it was very easy to provide the modified solution, both in the terms of civil and as well as structural steel elements. Models were also used in one of the project to report the status of engineering and construction activities. There are some strategic recommendation for the BIM implementation. If somebody choose to have a BIM, then these recommendations are very much helpful. We should adopt BIM in the early phase of design. See, certain people are there who are thinking of adopting BIM in a later stage. Let us prepare 2D drawings as a conventional, then we'll prepare a BIM model or a digital twin. So you are not able to fully utilize the BIM and get all the benefits which you might have got while using the BIM from the starting phase. Another suggestion is that if you are implementing BIM, you have to define clear-cut workflows process between the different stakeholders like mechanical, civil, and electrical teams to ensure seamless integration and minimize the conflict. People should invest more in BIM training and technology so that this technology can come up with more application and more benefits to cement plants. Use of BIM in continuous construction monitoring. See, we should leverage BIM tools for the real-time tracking and decision support throughout the construction phase to enhance the quality control and schedule adherence. Most important topic these days is AI. So AI is applicable for BIM also. BIM can be automated and AI can be used for the processes which are repeatedly done while using the BIM. This will reduce the time of engineering and increase the efficiency. Let us conclude now. Cement plant construction require modern solutions to overcome delays, errors, and inefficiencies which are coming through the traditional methods. BIM provides a powerful framework to integrate design, engineering, procurement, construction into one collaborative platform. With BIM, companies can achieve better ac- planning, accurate cost controls, early clash detection, and improved safety. To fully realize the benefits, the industry should embrace BIM, invest in training, and encourage active stakeholder participation. Holtec, with a proven expertise in many projects for the BIM, is ready to support client in this transition, ensuring faster, smarter, and more sustainable project execution. Thank you.